So previously we've talked about two things. I kind of introduced two things at the start of the topic. Arithmetic things and geometric things. And we haven't looked at geometric, I beg your pardon, yet. We're still looking at arithmetic. We've looked at sequences, and we talked about sequences being individual terms in a list of numbers in a sequence. And now we're going to look into series, which is actually summing all the terms or adding up all the terms in a sequence. We don't usually write it as a list of the things that have been summed up, but we can if that's useful for us to kind of see what's going on. So let me show what we've done so far. So the sum of the terms, adding up all the terms. This word sum means adding up. I'll put that in purple for you. The sum of the terms in an arithmetic sequence. Remember arithmetic, that means adding things. So adding things each time that are constant. So you might be adding 2 each time. You might be taking away 3 each time, so adding -3. You might be adding 4 each time, you might be adding 10, but you're definitely not multiplying by the same number. I'm just adding. So in this sequence, and I reckon we'll be able to recognise this by now, if not, head back to the last videos and watch them a bit more. Our first term is A, which is 1, and our difference is 1, so I'm adding 1 each time. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 1 is 6, and we keep going. So if we want to write that as a series with the same series, so A is 1 and D is 1, first term 1, difference 1, we could write the series like this. Here's the first term 1. The second term, however, is the first 2 added together. So 3 is 1 plus 2. And then 6, the third term in our series, is 1 plus 2 plus 3. And then the fourth term, 10, is 1 plus 2 plus 3 plus 4. So, for instance, if we wanted to find the sum of the first 4 digits, we would know that's 10 from looking at this, but we probably wouldn't have this. We could add up or sum up the first 4 numbers in the sequence. So the sum is what we're looking at now. It's the series. If it helps to remember, no, that wouldn't be useful to you at all, sorry. So adding up all the previous terms is basically what we're doing there. So 15 is all the previous terms added up. 1 plus 2 plus 3 plus 4 plus 5. So they gave us a neat little formula to do that with. This is the sum of the first n numbers, so it might be 6 or whatever, is that n divided by 2 times 2a plus n minus 1d. You probably recognise this bit, this a plus n minus 1d part that comes from the arithmetic sequence formula. It is derived from that, we get it from that. And as always, n is the number of the term, a is the first term, and d is the difference. So that's the same in all of them, in the arithmetic and the sequence and series. So find the sum of the first 4 terms of the arithmetic sequence. So we're still looking at the sequence. This is still information about a sequence, but now we're going to find the sum of the first 4 terms. So adding the first 4 terms. So we just need to use this formula with n as 4. So I've done that here. Here's the formula for you. And in this case, we're looking for the sum of the first 4. So we're going to go with n is 4. And I've just listed down for you what a and d are. So a was the first term and d was the difference. So this is pretty much what we're prescribed, given in the question. Now let's kind of put that in. So if I want to find s of 4, the sum of the first 4, there's my n there, 4. There's my a, there's my n again, and there's a d. Once I work that all out with my calculator, we'll get 70. Sometimes, particularly in the book, you'll see square brackets for the big brackets, round brackets for the small brackets. Whatever you choose to use in your calculator, it needs to be the same. So you can't use some square and some round in a question, or it will not work. So just use multiple sets of brackets. And I suggest round ones, because round ones are the easiest to use. But don't do square ones here and then round ones here. Otherwise your calculator will complain it won't do it for you. And then you'll complain because it won't do it for you. So yeah, just use the round brackets. So once we sum up all of these first 4 terms, it should equal 70. And we could check that if we want. So let's do a quick check of that. Sum of the first 4 terms. Remembering the first term was 10 and the difference was 5. So here's my first term, 10, and my difference is 5. So my second one's 15, my third one's 20, my fourth one is 25. And we're looking for the sum of the first 4. So let's quickly sum those ones together. 10 plus 15 is 25, plus another 20 is 45, plus another 25 is 70, which is really good. That's what we're looking for. So thank goodness we used the formula right. If we had time in an exam, that could be a good thing to check, just doing that manually. Let's press on. So another question might say, find the sum of the first 20 terms of the following sequence. So obviously that's going to be a a much bigger number you could predict if you're adding up all the first 20 terms. And it's not even just going to be like, you know, the 20th version of this, 10, 20, 30, 40, 50. It's not going to go 60, 70, 80, 90, 100 and keep sort of going that way because we're summing things up. So for this term here, we've got to sum 50 and 40 and 30 and 20 and 10. So you can imagine it's getting pretty big pretty quickly. So my first term is 10, my difference is 10. I'm looking for the 20th term, so my n is 20. Put it in the formula, use my calculator, same round brackets all the way through, and it will tell me it's 2,100. Now, if you want to go and check that, you're very welcome to check that. That could be good for you to see kind of what's happening or how quickly it's growing. But I suggest that you don't check it and you just trust me. All right, example 4. Again, I've used the same things, A being 10 and D is 10. This time I'm being asked to find the sum of the first 3, and we will be able to see that from this sequence. So I put everything in my formula, I worked it all out, and the calculator told me it was 60. We can check that. The sum of the first 3 is these 3 here. So 10 plus 20 plus 30, that is 60. So 10 plus 20 is 30, plus another 30 is 60. So it's not broken, it works. You can trust me on that one for sure because you can check it. For the following sequence, find when the sum first exceeds 1500. This is a pretty common question, particularly in practical examples, like they might want to know, a company might want to know when they've produced a certain amount of oil, for instance, and when they've produced 15,000 tonnes, they've got enough to break even for that month or something. Or if you've only got 15,000 or something, once everything is added up to 15,000, then you have to stop producing things because you've only got 15,000 to produce or something like that. So this one comes up a lot in practical situations. So let's get some practice at these. So here's my sequence. It starts with 0. That's not very common, but that's fine. So 0 is my first term, and each time I'm adding 2. So my difference is 2. So I'm trying to figure out when the sum first is more than 15,000. So remember that more than, that will be useful. Exceeds. So the sum is 15,000. Let's ask our calculator when the sum is 15,000. So we use this formula, but instead of this time putting in the n here and the n here, we want to know that. So we're going to put in this s of n instead, which is 15,000. So we're going to say 15,000 equals n on 2, 2a, and we'll put in the a, plus n minus 1, and we'll put in the d. Let's do that now. So s of n equals n on 2. I put in my a there and my d there. It's still being made equivalent, but we haven't got this n. That's the thing we're missing, and we put in the 15,000 instead, like I said we would. So we're saying when does 15,000 equal this formula that we have? That's a 2. Sorry, I mucked that one up when I drew it. And we ask the calculator, solve 15,000. You would know menu algebra solve by now for sure. We want to ask it what n equals. It's going to tell us n is 122.976. So, after we've summed the first 122 and almost 123 numbers in that sequence, that's when it's going to total 15,000. So it's to get up to 15,000, we're being asked for when it first exceeds, do you remember in the question? Sum first exceeds 15,000, but it's hitting 15,000 almost at the 123rd term, and it hasn't hit it obviously at the start of the 122nd term. So 122 terms is going to be less than 15,000. 123 terms is going to be more than 15,000 because that's exactly when we're on 15,000. And we can't really have half a term. That doesn't really work in practice. So we have to pick either 122 or 123. So we're going to round it up because it needs to be over and exceed that amount where it crosses. So it first exceeds 15,000 after 123 terms. And it's not essential to check, but if you've got time in an exam, you may as well check. So I checked, the sum of the first 122 was less than 15,000. Sum of the first 123 was just over 15,000, which is good, because that's the term when it first exceeds 15,000. It hadn't exceeded it here, and now it has exceeded it. Let's keep pressing on. This is an example straight from your textbook. I suggest that you watch me do the example, and then you try and do it yourself, and you can go back and do it that way. And see if you remember, and then if you struggle again, then you might want to work through it with the video a second time. So a child makes a pattern with blocks on the floor. She's putting 55 blocks in the first row, 50 in the second, 45 in the third, and kind of continues. So you can imagine if you're drawing the blocks here on the floor. There's my blocks. and there's going to be, that'll keep going. There'll be 55 in the first row, and then in the second row there's going to be 50, so there's 50 blocks coming out. Now I can't be bothered drawing 50 blocks, so I'm only going to draw 5. You can assume that goes all the way to 50, and then all the way down the next one will be 45 and 40, and continuing all the way to 0. So the first thing we're being asked to do is write down an expression for the number of blocks. So we're not being asked to find any sum sort of thing, so we can expect at least for the first bit we're going to be doing a sequence kind of formula. So that T of n equals a plus n minus 1d formula. You might remember that one. I'll put it here for you. Hope you remember that one. That's the arithmetic sequence formula. If not, keep practicing. I reckon you'll remember it by the time we get to exams. Alright, so let's write down the expression for the number of blocks. So we know in the first row there were 55 blocks. And then in each row there were 5 less blocks, so the difference is minus 5. We're adding minus 5. So taking off 5 each time. So 50 and then 45, then 40. That's arithmetic, it's a good thing to check. It didn't tell us in the question, even though we know we're doing the arithmetic sequences and series part of the module. It probably is good to check it's arithmetic anyway. We know the formula, I told you that a minute ago. So let's put in the 55 and the 5 into the formula and find the general rule. We know how to find the general rule, we've done that in an earlier video. So 55 plus n minus 1 times negative 5. And we used our calculator to expand it. You remember we did that as well in an earlier video. And it told us that the rule was negative 5n plus 60. So there I said the general rule is Tn equals negative 5n plus 60. So back to the question, write down an expression for the number of blocks in the nth row. The number of blocks in the nth row is negative 5n plus 60. Fantastic. So the next thing we're being asked to do, B, determine the number of blocks in the 7th row. So we're just looking for T of 7 really. I reckon you'd be pretty good at doing that by now. T of 7, and here's my formula, so I've gone negative 5 times 7 plus 60. That's there for you. And that was 25. So the number of blocks in the 7th row, 25. Alright, what are we being asked in C? Determine the total number of blocks in the first 5 rows. See this total number? If it says total, usually that means sum. So it'll either say sum of or total. I think that's the only 2 buzzwords that we hear. But total number of blocks in the first 5 rows is the 55 and the 50 and the 45 and the 40 and the 35. And we could do that by hand, but let's use the formula because that's what we're here for. Total of the first 5 rows is the sum of the series. So find S of 5. And then we just put in our formula. S of 5 equals, and pump in our N, our A, our D, party time, 225. I just used my calculator for that. So from here, that was a calculator job for me. Next question, D. How many rows can she have in her pattern if she has 300 blocks to play with? So it's decreasing each time. She's got 300, and obviously she's used 55 of them here, and she's used 50, and she's used 45 here. She's used probably about half of them already, but because it's shrinking each time, you expect it to take a little bit longer than 6. Let's say how many rows. We're going to solve for when 300 equals the total sum. So if the total sum is 300, that's what we want to solve for, and we want to know what this n amount is when that occurs. So we're going to put 300 equals and then put everything in the formula except for the n. The calculator gave me this answer, n equals 8 or 15. That's a pretty weird answer, and it's kind of hard to explain why that happens, but the truth is it happens after 8 times. It's kind of because this formula represents actually a quadratic. You don't have to understand what that is, you just have to understand it's always going to be the first one. And because we're subtracting each time, we actually kind of went into the negatives, and then we were subtracting a negative number, and then we were adding back on again, so we went back to having 0 after 15 times. But the problem is, you can't keep making rows that have a negative amount of size. Like, once you get to 0 blocks in the, say, the 8th row, the 9th row can't have negative 5 blocks, because that doesn't make sense. We can't have that. So you've just got to remember it's the first one, and trust me, it will always be the first one. This one here is kind of like a bogus, because we have to follow the laws of physics with negatives, but we can restrict it to the first time we run out of blocks, because we can't have a negative amount of blocks. It will be the first one, is the basic what I'm saying to you there. So we chose 8 because it happens first. Negatives cause the problems. So we would state the answer. She can have 8 blocks in her pattern. Let's push through. I haven't got many more examples. I might stop the video there in case you're getting a bit fatigued. We'll start again and do a few more examples in just a second.